Okay, so in this video, we're actually going to walk through the process on how do you increase your CSOM code performance by 2,600%. And that is correct, 2,600% by following a few techniques within C# programming. So let's take a look at the code here. So what I have here, I have 6 different options. And what we're going to do, we're just going to do performance tests on these 6 options, loading and JSON data into a SharePoint list. So if this is your first time meeting me or watching one of my videos, this is one of a series to where we're actually building a job portal site within SharePoint 2013 using AngularJS and SharePoint, and it's going to be custom web APIs and all this other good stuff. But as we were building this, we needed a lot of sample data. So what I ended up doing was shooting a video that load JSON data from a file. It's 100,000 items in here into a SharePoint list. When I went through that process, it took forever. I think it took like 12 hours or something like that, something just insane amount of time. And then I started toying around with multi-threading, multitasking, and things along those lines, and increase performance tremendously. So what we're going to do, let's walk through the code and walk through these 6 different options that you have. So let's look at the first option. And before we go into, and that's going to be just add job items here. But before we go into that, let's just kind of get some background on how this is set up. So basically I have the URL to my site from in the app config. I'm hard coding the name of the list. Again, this is just test, but obviously you can make this more robust. And then from that list, I actually have this repo, is SP repo, which is like a manager or repository manager class. And it allows me to set up the client based on the URL and get the list by title. So now I have the list here. And then basically from that JSON file, I'm just taking this is probably 100,000 items in here. So for our testing, we're just going to start out with 100. And we're going to pass that 100 to this method here, which actually adds them to the SharePoint list, and it does the execute query and all that other good stuff to the SharePoint list. So if we do a deep dive into this, this is option 1. And, you know, I already did the plumbing to get this list. So I have the actual list object, and I have the JSON data, in our case, the 100 items that we're kind of taking a subset of. And I'm just walking through this simple for each loop. This guy here is just encapsulating the mapping. So let's just go here. You will see the mapping where it just takes all the JSON properties and dump it into a site column property, create an item, pass that back to the caller. That's the item there. And then it's not until this line here, line 73, that we actually do the execute query that loads this. So what I'm going to do, I'm going to run this job real quick, and I'm going to show you, we have a stopwatch here. I'm going to show you how expensive this execute query is for each and every call. And really, this is going to be the baseline of our technique. So this is just the standard way of writing CSOM code. And you will see that, you know, within these calls, you know, that's 763 milliseconds, 1.3 seconds, 824 seconds, just tremendously slow in the respective to code processes or method time it takes to complete. So let's just stop this. And so now you kind of see how expensive this is. So as a baseline, and I have a spreadsheet here to where we're going to go ahead and fill this out, and we're going to do it quickly. I'll pause the video in between runs and all this other good stuff. But then we'll look at all the different options here on how you can manipulate or code your CSOM. Same business logic. It's just really different coding techniques. And you will see how as we progress here, some of the different strategies that you can leverage to get past that 700 plus millisecond call that this one line of code cost us. Okay, so let's just do this. Let's just start and get our baseline. So what I'm gonna do, I have this line uncommented, and again, we're gonna do the test for 100 items, and I'm gonna just go ahead and execute this now. I'll pause the video, and then at the end of the video, we'll capture the results. Okay, so we're at the end of the batch 1 for option 1, and that took 78 seconds, 78.34 seconds. Okay, so let's just go ahead into our Excel file, 7834, and that's going to be our option 1. So this is going to be our baseline. Now let's look at option 2. So if you go, let's go back to our program. Let's comment this out. Oh, let me stop the debugger. 1 second. All right, so I have my debugger stop. And if I go into option 2, let's just take a look and see what the difference is. And basically, this is still going to be single task or single thread, a synchronous call. But instead of calling one item at a time, we're going to batch these. And right now, our batch size is going to be 50. So let's see what that means. So if we go into this method here, basically, you pass in the batch count, and it loops through the collection total. And for each batch, it's going to do those in chunks of 50. And the chunk is going to be, let's add 50 new items right before we call the execute query. So we're still going to, it's still going to cost us that 700 millisecond plus call, and I've seen this as low as 400. So 700 is a little bit exaggerated for the current network conditions that we're working in. But that's some of the things that you have to take a look at when calling the CSOM, that you have that variation. So this guy's just going to go in, queue up 50 items, and then call execute query. Go in, queue up another 50 items, and call execute query. And because we're only doing 100 items, we should see execute query only executed twice. All right, so let's go ahead and run this job. And as this is running, hopefully this should be pretty quick. Yep, so that's our first 50. And right now, that pause that you see, that's now we're on the server side at SharePoint, and we're processing those 50. And now it should come back with another chunk of 50 here in a second. All right. Oh, we missed it. So this one costs 19.6 seconds. So just by batching those, let me just capture that. Just by batching those calls, you get a 308% increase in performance just by the way that you segment those calls up. Okay, we still have a blocking call. So we really didn't solve the problem. We just got a little bit more efficient by working around the problem. So we still have this blocking call here, but we're sending more data for every time that we go across the network and process this on the SharePoint side. So that way we can increase performance that way. So that's one way. So let's look at option 3. So if we go down to option 3, this is where we're doing multitasking. Asynchronous call. So we're trying to get rid of the blocking call, but now we're going to go back to that single item at a time. And the reason why I want to, as we progress here, I keep going back to the single item at a time, meaning that there's so much work you can do before the execute query and execute. Part of that is because, like, say for example, if we're creating a site collection via CSOM, right? So we have a provisioning app. Most of the common scenarios is that in the business, the user requests that they need a site, they fill out a form, we drop that into a SharePoint list through a remote event receiver or something like that. We call a job that would take all their data that they want for their site collection, the type of site collection, like if it's a publishing site or team site or whatever the case may be. And then our CSOM code would then create that site, get that provision, and then send an email notification to them. Well, when you provision, if you get a batch of those, when you're provisioning those site collections, you're going to call execute query many times before that site is done. So this, doing one item at a time and, execute query, there's only so much you can batch before that. But adding items, deleting items, those are perfect candidates for batching. So let's take a look at this guy. So as we, and here's a huge difference here. As we kind of look at adding these items asynchronous, there's a few things that we had to change in our code. One, we had to treat this as a unit of work, meaning that this job right here is actually going to go through this process of, this method is actually going to go through the process of creating a client context on each and every load, and then finding that list per instance, adding one item, and then execute query on that item. Now, this may look very inefficient. It's like, okay, there's a lot of overhead because you have to hydrate a new client context each and every time, and then you're going to have to find that same list that you're going to reuse over and over for each item. You're going to add one item, and then you're going to disconnect, and then for the next item, you're going to go and do all this work over again. Well, this is important. Part of this is the reason why we have to do this is because by default, this client context is not thread safe. So what we have to do, we kind of have to do some workarounds, and we kind of have to fake it a bit. If you look at your object model in the API, you look for, you want to find this execute query async. That guy doesn't exist. We created a extension method that actually just dumps that execute query off onto a different task, so that way your current thread is not blocked. It can execute this as a task, it gets scheduled, the thread continues on and execute other pieces of the code, and then when this guy is ready, that's why you have the await. When this guy is ready, the thread comes back, process this, and say, okay, you're good to go. So this is a non-blocking call, but because the client context is not thread safe by default, maybe they'll make this thread safe in the future. I haven't looked at the latest CSOM object model or NuGet package for SharePoint Online. I know they updated that pretty aggressively compared to on-prem, but the last I checked, this still was an issue, and this is something that you have to do. So in order to get around this, you have to hydrate this client context and do all this work each and every time. So in our case, it's going to seem a little bit more inefficient because we're going to do it for each and every item. But the flip side of that is, though this seems like a lot of overhead and a lot of work, this is the same pattern that's needed for multi-threading, multitasking, and even if you want to write a serverless function, right? Because when you're writing a serverless function, basically it's that same concept that I'm going to pass in this function everything that it needs to do to get the job done, and not assume that it's going to pick up an instance of any object that was previously used. So this is just another pattern that we kind of have to get used to. It seems counterintuitive, but we kind of have to get used to if we want to set up for highly performant CSOM code. So that's the major change there. And then also we had to add that asynchronous method in order to do the client execute query on a separate task. So basically, so this guy is going to go out and for each and every item, hydrate the client text. We talked about that. It's going to return a task. And basically what this guy is doing is collecting those tasks, which is that unit of work and that schedule, right? So it's collecting those tasks, and it's going to wait until these are complete before this method returns back to the caller and says, okay, I have all your items added, even though within this method we separate this on different tasks so that each task can go and add these in parallel. And we want to get as many of those added in parallel as possible. So, and that really depends on your current environment, how many processing cores and all this other good stuff that you have. So by calling this, let's just see how it performs. Again, we're doing our 100 items. This is option 3. This is a multitask asynchronous call, but we're still only going to do one item at a time. All right, so let's go ahead and see what this looks like. I'll pause the video and then return when this is done. Okay, so now that job has completed. And if you look at the results, because it's asynchronous, it shows you everything that's going to be added. So this login is incorrect. So adding should be the real phrase, because it's not added until the execute query call is actually made. So this took 23.56 seconds. So let's go ahead and log that. So still a lot better than our option 1. So actually still a 232% increase in our option versus our option 1. Again, this is not batching. So this is one item at a time. And as I said, those scenarios where you have to call execute query many times before you get that unit of work done, this is probably your best option. This option 3 is probably the best option so far. We'll look at other options to make that work. Now, the only concern with that one, hold on, let me close this. Let me kill the debugger here. The only concern with this guy here is that, and you will see the difference between this and, actually, let me save that. I'm getting ahead of myself. So let's go back. Let's take a look at option 4. Option 4 is multitasking asynchronous, but this time we're going to add in batching. So if we take a look at this guy, let me collapse this, expand this one out. We're doing the exact same thing that we did in the single thread. So we're passing in the batch count, and it's going to do this in chunks. Right here, just an efficient way. This is actually something I found on Stack Overflow when I was looking for another issue. I saw this really cool way of, if you wanted to do this in batches, basically you take the count, you increment this by the number of batches, in our case 50, and you use skip and take to efficiently grab those chunks of items within a collection without having to iterate through them each time. So really just kind of leveraging LINQ to get that batch out for you. So again, so we're going to take a subset of those jobs. We're going to pass it to this method here. Let's just take a look at this guy. And this is going to have the same approach where, now I have the jobs. I'm going to load as many items as possible before I execute query. I'm going to still call execute query asynchronous, so it's not a blocking call. And then I'm going to return this guy back to the caller as a task, return my task back. And then this method here to keep this synchronous, right? So this chunk right here is asynchronous, and now we go from asynchronous back to synchronous because we don't want to return back to the caller until all of the work is done. So that's what this wait all is very important piece to this process. If you process this without the wait all, what will happen is that your job, your program, that CS is going to complete in like 2 seconds. But then if you look at your SharePoint list, you will notice the count, even though the job says it's done, the count is constantly increasing because this guy here is actually running in the background, and our main thread did not wait for all those tasks to complete. So we kind of get like a phantom performance where it's like, oh yeah, wow, that job is done. It finished in 2.3 seconds, but the job is actually still running and executing in the end. And that's also dangerous because if one of these fail, right, and we talk about error handling, and that's one of the issues with batching. If one of those items fail, then now you have to write recovery process that says, okay, which one of the items failed in the batch? Did I get all 50, or did I only get the first 20, or where there's scenarios like that. But in this case, if you don't wait and if something here fails, you have no way to recover from it. You have no way to even knowing that it failed because your main thread has completed already. All right, so enough yapping. Let's go ahead and see the performance of option 4, which is a multitask asynchronous batching process. So let me start this, and I'll pause the video. And once this is done, I'll go ahead and bring it back. Okay, so just a few seconds after I paused the video, this guy completed, so 15.1 seconds. So let's go ahead and log this performance time here. Not too shabby. So far, this seems to be our winner. So, even so, if we're batching with single thread blocking calls versus batching with multi-thread asynchronous calls, there seems to be like a 4-second performance increase there. But obviously, all of this is better than our main single thread, single item, one at a time. So right now we're at a 418% increase. All right, so let's go ahead and move on. So I talked about multitasking. Now, this is something that it really took me a while to understand this, right? Because, I think the asynchronous programming and multi-threading programming in C# is because we're so used to single thread blocking calls. That's how most of us learn how to code, that when we starting to get to this asynchronous multi-thread, it becomes counterintuitive, and we kind of have to manipulate our code a little bit different, especially on the CSOM piece where you're dealing with objects or API that may not be thread safe. There are certain hoops or things that you have to do, and on the surface it may seem very inefficient, but in the end, as the data shows you, it's actually a very high performing way of doing things. Now, I did this the long way. Now, I would say these option 3 and option 4 are probably legacy on where you're actually managing tasks and creating those tasks and doing the wait and async. But as of C or .NET 4 framework, there is this thread parallel library or task parallel library, TPL. And basically what this allows you to do, that Microsoft has really simplified the process. So basically they say, okay, if you have a for each loop and if you have a synchronous, right, just as, because this is the way we code, we have a synchronous job, all you have to do is wrap that into this for each loop and do this fat arrow type notation and put your code in the middle, and this will magically create the multi-threading pieces of the code on the multi-threading processing, and process this code efficiently, the most efficiently based on the environment. And now this may be vary, right, depending on that amount of activity that you have on the server at the time that this job runs, but it manages all of that threading and all this other good stuff, and it also has the hooks. If you do a Google search on C# TPL or parallel library or things along those lines, it also have many different options and hooks on a proper way to cancel the job, or if you get an exception, it's an all or nothing, so you can cancel it, or how you can do try-catch blocks and all this other good stuff. So they have all that baked in. I'm still learning how to do this, but it just seems like a really easy and efficient way to do this. Now, because we're still dealing with client context and it's not thread safe, we still have to build this client context, get the library or get the list, and then add the item, and then execute query. So we still have to do this plumbing up front. That part is not going away, but you just really add these 2 lines of code, really just 1 line of code, and make sure that you have the right proper syntax to make this work. Dump everything your existing methods here, right? As long as you position them to, and the best way to look at this as a unit of work, meaning that you start from the very top. Here's my URL. Go through the process of creating a client context and execute queries as many times as you need until that unit of work is done. That's what you dump here, because if you have to do that X number of times, that's the for each loop that's going to do that, and it's going to make that more efficient for you. Okay, so let's take a look and see. And again, this is single thread. This is blocking call, but it's multi-thread processing. All right, so let's go ahead and try this. Did I uncomment this code? Yep, let's go ahead and try this and get the numbers. I'll pause the video. Okay, so now we're done. This is, it finished in 22.04 seconds. Let's go ahead and record it. And then I want to actually take a look at this. And we can go back and take a look at all the other ones. We know that calling these items one at a time versus batching, where you can leverage batching, when you can leverage doing as much as you can before execute query, you definitely want to do that, right? But it's interesting how the way this gets logged out is that you have execute query peppered in many different places, because that's the thread completing. You had one thread that took, maybe this item, and then it completed, and the next thread took the other item. So it's interesting to see how this multi-threading, the results of this, and how it spits out, how it logs out the information, because, all these threads are coming back in different times, right? They're finishing their work. They're reporting back to the main thread. They say, okay, this is done. It's okay, now you can go grab another one. So you really, maximizing the efficiency and utilizing as many threads as possible. But unfortunately, this is still a blocking call. So each thread is actually sitting there waiting for this execute query to complete, and then it will report back before it grabs something else. Now, the next one, we're going to actually mix 2 of the same, let's stop this. We're going to mix 2 of the same concepts, only because I didn't want to make this video too long. But I wanted to give all these options and the results of all of these right away. But in this other one, what we're going to do, not only are we going to leverage multi-threading, and not only are we going to do it in batches versus a single item at a time, but we're also going to combine multi-threading and multitasking, or asynchronous processing, at the same time, right? So this is throwing everything that we learned on the table as far as efficiency. And the old saying is still true, that performance increases is really the death of 1,000 cuts, right? So, it's not one thing that's going to increase performance, but it's a combination of different things in the right scenario. And that's what we're going to use. So we're going to do this. I had to do something weird with this batching though, only because with this for each, there's a for each and there's a for loop. As you remember in the past, for my index, what I did in order to jump by 50s or to do things by hundreds or 20s or whatever, I added the index by that batch number. But for this for each process, it did not allow me to do that. It wanted to do things sequentially, looping through the index one item at a time, versus allowing the way to jump through that. There may be a way to do that, but from a syntax perspective, I couldn't get it to work. So I had to pull that batching out into this job here. And really, basically, there's still using link. You use the select, and you leverage the index of the item. And it is really this group by syntax here, or algorithm or strategy. This is the one that groups it by whatever my number is. So I'm still grouping these by 50s, but now I'm passing this as batches of 50. And this one item here within this batch collection will represent a group of 50. So now if I migrate this to a list, if I cast this to a list, then it flattens it out. So now I have 50. So I'm still passing 50 items to my sub method. Again, this is still true where I pass in the URL and the title, right? And it's still going to do all this plumbing, but it still takes advantage of adding as many as it can, or really based on the batch before it calls the execute query. This execute query is an await or asynchronous call, so the thread is not going to be blocked. We're going to add that thread to a list and make sure that all of them complete before we return it back to the caller. And again, this took me a while to figure this out, right? It was wall after wall after wall. Maybe I'll go through a video to where I actually build this from scratch and really kind of walk through step by step of the process and the things to consider and ways that you need to, changes you need to do to optimize it in order to get these numbers. But as of right now, let's just go ahead and execute this and see what the performance is going to be. I'll go ahead and pause the video, and then once it complete, I'll unpause and we'll review the result. All right, so it's done. So that took 11.78 seconds. Right, and this is the one that based off these numbers, 565% increase in performance. Now the promise was 2,600%, right? And we're going to get there. But as you can see through these different options, there is a fair amount of overhead. And that's why, obviously you would say, okay, well, I'm going to do number 6 in everything I do, right? I'm going to, we talked about this, that, there's scenarios where you can't use batching. You have to do things one at a time because it has to be synchronous and all this other good stuff. But there is some overhead using multi-threading, even multitasking. So options 3 through 6, depending on the count that you're going through, and as you can see over time, right, these numbers, obviously these will be the winner, but there is a threshold to where these actually shine versus the other ones. So, if you do option 5 versus option 2, you're actually losing in that regard. But then again, if you're looking at, all the other options, just looking at these numbers, you can tell that, 5 and 6 is probably your go-to. And personally, just the difference between the multitask versus the multi-threading, especially if you're using the task parallel library, the coding, the way that you transition from a single thread, blocking code pattern to a parallel is very minimal, right? Whereas going from option 1 and 2 to option 3 and 4, it actually took me a few days to figure it out, just banging my head against the wall. And I still don't think I got it 100% because I still think that option 3 and 4 will not support if there is an exception thrown. How would you recover from that? So what I'm going to do, let me pause this video. I'm going to run through all the tests for 500 items and then 1,000 items and 10,000 items. And then before each step, I'll just record, I'll unpause the video, show you the results, and then we can kind of draw a conclusion from there. All right, so I just completed the 500 item test. And if I bring up the spreadsheet, these are the results. So option 1, so we baseline with 300 seconds just to get 500 items, single thread. Once we started batching, that came down tremendously. I mean, by almost a 600% increase in performance. Just by doing this in multitasking, with asynchronous calls, right? So just making this asynchronous, we still cut that down in half if we did single item, one item at a time. by like 300%. And if we're able to batch those, that's when the magic really happens. It's just amazing how, if you're able to get a lot of these, again, we're only sending 50 at a time, but if you're able to get a lot of these in there and you throw these on different tasks, right? You, 2,600%. And then you got these guys here are just multi-thread, and this one is the magic one where it's multi-thread and multitask at 11.64. And again, just a lot of overhead. But here's something that's very interesting. We did 5 times the amount of data, right, from 100 to 500. When you look at these numbers here, they're very close. And I think that's the power of multi-threading, is that, regardless of, not really regardless, but with more data, you can get a lot more done fast. And if you don't optimize it, right, and if you don't really leverage it, it's almost having like a V16 engine vehicle. If you're only doing 30 miles an hour, you're not going to really see the big difference in what all that engine will give you, right? But it's not until you do, you crank it up and you're actually going, high speed, a lot of data, making it be the workhorse that is built to be, that you really start to get the performance gain out of it. Now, if we drop down less than 100, it'll be interesting to see if this number even goes up, because as I mentioned before, even with multi-threading and multitasking, there's a lot of overhead needed to set those guys up. But once you're going, if you got a bunch of data to throw at it, you can really see the benefits of that. Okay, so let me pause the video. Let me go ahead and run the same test through the 1,000, and let's see what. Okay, so we just completed the run for 1,000 items. And as you can see, the numbers are steadily increasing here. We're adding more data. The time is taking longer. For option 2, what we do with batching is still, pretty good. Still outperforming the single item one at a time. Option 3 with the multitasking. This one was actually surprising. I was expecting this number not to be as high, but it is what it is. Maybe there was a network condition at the time of the run. One of the things I do notice is that usually I can shave off 2 to 3 seconds if I run this multiple times for the same job, which probably would explain these difference here. You have more data, but it takes less time than with less data. Part of that is, just overhead, and some of that is network conditioning as well. But we're still consistent as far as performing as good. This one too surprised me. I thought this would be would double the data, not necessarily double the time, but this is really close to double the time. And then obviously the optimum way, option 6, where you have multitask and multi-threading with asynchronous calls, is still performing very well. So that's so these 2 options here, where you can do batching and asynchronous calls, you have almost a 3,000% increase in performance. Now, the one thing I probably would do with this option 5, right now this is multi-thread, but it does have a blocking call because it's synchronous. I would probably change this code a little bit to do multi-thread asynchronous and see if these numbers would change. I'm not going to do that now, but I'm just thinking about it now. Now I'm looking at these numbers. But either way, all of this, as far as option 1, all of these numbers are definitely outperforming this way. So this is probably the worst way of doing it. And surprisingly, 96 to 97% of CSUN code out there now is doing option 1. And that's just because, it's just new. And I think the development community within SharePoint is just starting to grasp the understanding of these remote calls and the cost of that execute query. And now we're starting to get through, from performance issues and concerns that may arise, because things are going to be a little bit slower because you are in the cloud, you jumping over network hoops and all this other good stuff. I think now folks are starting to realize, okay, what can we do to make performance that much better? So let me do this last run for 10,000, and then we just actually wrap up and talk about next steps. Okay, well, that was an exercise. So we finally finished the 10,000 run, and here are the results. So for option one, single threaded, single task, everything singular. 90 minutes. So that 5900 is roughly around 93 minutes or something like that for that. And then 525 for option two. This is where we do batches. Option three and four, again, this is where we do multitasking. This is single item multitask, and this is batch item multitask. And option five is where we do multi-threading, and this is multi-thread single item, and this is multi-thread and asynchronous multi-items as far as batches. And I think this is your best case scenario. So 6,400% increase for the multi-thread asynchronous with batching, a 5,700% increase in performance when you do it multitask and asynchronous. Again, just the cost of a blocking thread and not batching can cost you a lot, right? So not only so if you look at these numbers, right, not only are you performing better, but when you do batches, which is these guys here, you're actually doing more with less transactions over the network. And this becomes a cost savings as well, because when you're in Azure Web Jobs and Functions, you get charged by the transactions, like the number of transactions that you have. I want to say that's true. I know that's true for the Azure Service Bus, but depending on the asset that you're using in these cloud services, in AWS and Google Cloud, and all these guys are starting to follow that same model. Some of them charge you by CPU power. Some charge you by the number of transactions you generate through your job. So all of this has a direct relation or correlation to actually saving money. So not only are you performing and saving on time, but you're also saving on money. And this is significant, right? So, if I just highlight a few of these items here, I mean, this is 93 minutes versus 90 seconds, the same amount of data. I mean, that is so significant, and you can sell this many different ways on why you should be doing this and why this should be becoming your new coding pattern on establishing multi-threading and asynchronous non-blocking code patterns, not only with CSUN, but you can use this whenever. I mean, even if you're writing custom REST APIs that have CSUN framework to go against SharePoint data, you're going to have the same. And this code becomes a little bit more simpler when you're doing like the HTTP client, which by nature is going to be a built-in asynchronous method, and you don't have to fake it the way we did by throwing the execute query on a separate task and then just with an extension. So again, this is all new to me, and I'm still learning all the ins and outs of this. But as I learn more, I will create more videos. But this is just fascinating. Just looking at the numbers alone is very fascinating to me, and something that I definitely want to become more skilled with and learn how to handle this, especially with exception handling, error handling, things along those lines, how to handle that properly. So again, I would say I would highly recommend share this video with any SharePoint developer, SharePoint architect on your team. Make sure that they are aware of the different techniques. The results are astonishing, and I think it will have a great impact on your organization to speed things up. Again, in this cloud first, mobile first, everything remote service and microservices, everything going across the wire, it becomes very, very important to do this stuff as efficient as possible and as quick as possible. Not only does it save time, but it also saves money. That's it for this video. I hope that was helpful. I will drop this sample code into the description. So definitely go ahead and grab that. I will kind of leave everything intact. The only thing you have to do, I will even throw a copy of this JSON data in there too. 100,000 items of sample data. I'll go ahead and put that in there so you have something to test with. And then when you get to the app config section, just go ahead and drop in your URL and your credentials and all this other good stuff so you can get connected. So again, I'll leave all of these 6 options there in the SP repo section. It has all of the code in there. You're going to also see some dead code there where I did a lot of try and catch. I'm going to leave that in there as well. So that way you kind of see what I kind of morphed out of, or things I did try and probably found a better performing way to handle those different scenarios. Definitely leave me your feedback. Let me know what you think. Let me know if this helps at all. But I think, as far as increasing performance in SharePoint Cloud solutions or even remote solutions on-prem, this is definitely a key. All right, take care, and I'll see you in the next video.